Putting you live in now. Awesome. In theory, we're live.
Nice.
In theory.
I did notice everyone get really quiet all of a sudden.
Shh. Let me see if I can find the chat and then get some kind of external confirmation of our existence. Nope. Nobody's saying that we exist yet. So it's still saying, so in YouTube, it's saying that you need to change the video resolution. The current resolution is 1280 by 720, which is not supported for this configuration. Blah, blah, blah. Warning from YouTube. I don't know if you care, Pamela. It's saying that you need to change the video.
Does this mean I get to keep eating dinner?
No. People just won't be able to see you eat dinner in thrilling 4K. They'll just see you in 720p. So for some reason, it's being output is 720p. It looks like. Yeah, no, absolutely. I just, how does that happen? Like how? No. Like how does it change? Like, don't you just use the same resolution every time? Okay, all right. Funny. Yeah. Oh, there you go. Serious Kaylee says, I see you at 720p in Texas. So there you go. We're coming in with all of the resolution of 1997.
Dial up.
Yeah. So
that should be a new theme.
I remember dial up.
Hangout.
I don't know if anybody is keeping. I'm sure you're all keeping track of the hurricane, but what a nightmare this hurricane is. So it hit Fort Myers just like about an hour ago, and the storm surge is like 8, 9 feet, 10 feet, growing. So the storm surge is still going up. You're seeing houses get inundated. I've seen videos of streets getting filled with water. 140 sustained miles per hour. At landfall in Fort Myers, there's like 750,000 people who got a direct hit. But Tampa, all these places around it are right. Oh yeah, it's a nightmare. This will go on record as one of the worst, most devastating hurricanes to hit the U.S.
I'm just going to say that the trend of geologists planning field work continues. Because my research group was about to do field work just outside of Tampa, starting Sunday.
So you were like summoning a hurricane to... Yeah.
Evidently. I'm really sorry, Tampa. It's not my fault. But the hurricane is like going out of its way to just avoid Tallahassee.
Yeah. Oh, is it like the equivalent of like when an astronomer buys a new telescope and causes weather conditions for...
Oh yeah,
it must have
been a huge
field work.
Sounds like it.
Definitely rained.
Yeah. Anyway, so if anyone's watching right now, you're in the area. You can't see us because your power has gone out and your internet's down, and you can't leave. So stay safe. I hope
Stay
everybody
safe.
is as safe as possible.
Please.
Yeah. All right, well, let's get started. Welcome to the weekly Space Hangout for Wednesday, September 28th, 2022. I'm Fraser Kane, the publisher of Universe Today. This week, we're going to be talking about the DART mission, obviously, what to see in the fall skies, new information from Perseverance at Jezero Crater, and looking at lunar glass to understand Earth's impact record. Joining me this week, we've got Alan Bursfeld. Hey, Alan, how's it going?
I'm doing all right. I'm just very glad we have electricity, so I can.
Oh, there we go.
Good. You can hear me. Yeah. I thought it was. Everything's going wrong with us.
Yeah.
In South Africa, as you might remember, we don't have electricity very often anymore. It is absolutely crazy, but we've got some now.
Yeah, good. Hold on to it. It's like
so I'm here.
put
That's
it
great.
in, like store some of it, take some electricity, just put it in your pockets. It'll be fine.
Yeah, I was worried. I got a
Um,
UPS busy
all right.
charging up in the side here. Anyway, if it's too noisy, let me know.
We've got we got Pam Huffin. Hey Pam.
Hi. How's it going?
You back
Love
in the new
your background
season.
in your new house.
Yeah.
Thank you.
I'm not hovering in front of some space object anymore to hide the fact that I'm living in a tiny trailer, dying a mold death. I'm in a house like a regular person. It's very
Bravo.
civilized. Yeah. And this is
Very
it. This
cool.
is my forever home. And we've got Dr. Nick Castle. Hey Nick.
Hey, Fraser. How's it going?
Good, and you're welcome back. This is your second episode this season, I think. You were here.
I believe so. And my
Yeah.
third is next week. And my
You
fourth
are-
is the week after that.
You're a trooper.
It's all good. I enjoy it.
Yeah, no, good practice. Good practice. It's all we are just training you, turning you into a science communication beast. So
Look, see, if you invite me back often enough, I'll just have to publish my own papers so that I can talk about them too.
I'm amazed that you don't. That should just be like 101. All right. So before we get into this week's guest, I want to give a huge thank you and a shout out to our good friends of the Weekly Space Hangout crew. They are our friends, our fans, our executive producers. They call the shots. We do what they say. They organize the guests. Mostly Nancy organizes the guests, but still, anyone who is a member of the Weekly Space Hangout crew can participate in these functions. So go to wshcrew.space to join this amazing community, and you too can control me, who I talk to, who I interview, like a puppet. So wshcrew.space. All right, we've got a very special guest this week. We've got Dr. Ashwin Vasavada. Dr. Vasavada, welcome to the Weekly Space Hangout.
Hey, thank you very much. Great to be here.
So the question I always ask people, who are you? What do you do?
I'm currently the project scientist for the Mars Science Laboratory mission, but better known as the Curiosity rover. And I work at the Jet Propulsion Laboratory doing that. Been in this role for about 7 years now.
Wow.
And I get the honor and pleasure of leading this huge team of scientists involved in the rover mission.
Curiosity is still going strong. Like, all eyes are on Perseverance, but Curiosity is still delivering on the science. How is the rover doing right now?
I'm really glad you noticed that. We are definitely taking a second seat over from Perseverance these days.
Yeah,
but we are doing great. The rover's doing really well. In fact, yeah, I know it's hard to compete, but I think if you asked us how the rover would be doing 10 years after landing, we probably would have all thought less well than it's actually doing. Mm-hmm. We're still able to do all the science in the ways that we were able to do even during the prime mission. Things we have lost some capabilities here and there, but nothing major so far. So fingers crossed, knock on wood, we're going to keep going for a few more years.
But lots of power. The wheels are doing okay. None of the science instruments are in safe mode. Everything is rolling.
Yeah, all 10 instruments are still working well. We've lost, small capabilities in a lot of different systems, but nothing that's taken out a single major capability. And so, we are finding workarounds for various instrument capabilities and various rover capabilities, but we're still doing all the science we ever did. The power is maybe now 2/3 of what we landed with, which is worse than it sounds actually, because you need like half of the power just to kind of keep the lights on. So the amount of discretionary power we have left is getting low, but we're able to make use of it very nicely. And the wheels, are in bad shape, but they've been in bad shape for many years, and we've managed to drive in a way that kind of keeps them steady. They're not. We're no longer worried about that being the limiting thing on the mission.
So where is Curiosity right now in terms of like the larger mission? Like, we've all been watching as Curiosity has been, I almost call it perseverance. That's weird. Anyway, we've been watching as Curiosity has been sort of climbing up the flanks of Mount Sharp, making a bunch of really cool observations. Where are you right now?
We are at a place that you can actually see pretty clearly with your eye on images of Mount Sharp from space, because there's a big change in how the mountain is expressed. It goes from kind of a smooth slope at the scale of the orbiter images to all of a sudden the appearance of all these rounded buttes. And that has been recognized from even before Curiosity, our landing, as what we call the layered sulfate unit. The rocks that form these rounded buttes are also very obviously layered, even from orbit. You can see that. And from the MRO, the Mars Reconnaissance Orbiter CRISM experiment, you can see that those rocks have a signature of magnesium sulfate. So yeah, there's a good picture showing that. We're right there where the arrow is. I love this picture because we took this on Sol 23, staring at this mountain, kind of drooling, hoping we would get there one day. And there we are where the arrow is.
That's amazing.
In this sulfate unit. Yeah, which is a place that we always wanted to get to. And we can talk more about why.
Yeah. So like, what makes this spot so special?
Yeah, we've been climbing the mountain, as you mentioned, and we've gotten about 600 meters of vertical distance below the rover now. So it's been quite a climb. And the goal of reaching Mount Sharp and doing this, even before landing, was to access these various layers that change in their mineralogy that we even saw from orbit before landing. And what made that interesting is because the changing mineralogy means a different environment early in Mars history, going from environments that formed this iron oxide hematite that you see labeled there to environments that formed clays, which we think are the best ones for the possibility of life. And then now to this brand new unit we just arrived at, the sulfate unit, which is more salty, you can think of it that way, and maybe represents climate change from wetter to drier conditions. So we're really excited to figure out what that means for Mars climate. And then, of course, what that means for the possibility of life.
I mean, it really makes sense that you see evidence of water down at the bottom of the hill at the lowlands, but now you're so far up the hillside, you're starting to see this like, is this the edge of a salty sea? Like, what do you think explains this?
It could be. There's some discussion still of how deep the lakes in Gale Crater ever were, and it's possible that some lakes were as deep as the floor of the crater all the way up to that arrow. But what probably has happened is something different, which is there were shallow lakes, and those lakes deposited a floor of sediment, deposited sediment at their floors, and slowly over time. Kind of like you have a water glass and you keep putting sand in it and the level of the water keeps rising. Mount Sharp and Gale Crater kind of filled that way. And so there was a lake era where you progressively laid down layer by layer of this mountain with lakes. And then at some point it dried up and maybe the rest of the layers formed just at a dry process, like sand blowing in or dust falling. So maybe we're at that boundary where the layers of the mountain formed in lakes to forming out of air.
Right. Okay. Now, I mean, in going to Mars, like the main goal with Curiosity was to find evidence that there was once water on Mars acting for long periods of time. And I feel like we've seen so many examples of this. Are there any versions of that you haven't seen yet that we see here on Earth and you're like, boy, I really hope we see this indication that there was water on Mars as another line of evidence?
Yeah, that's an interesting question. When we first landed, one of the things we saw immediately, and I think maybe this is like my fourth graphic or so, was a bunch of pebbles littering the surface. And those pebbles were rounded. And that was evidence. We all know this on Earth. You go to a riverbed and you have rounded pebbles at the bottom of it.
Yeah.
Something we always suspected was happening on Mars. but we saw it with our own cameras, our own eyes. And then we got to the mountain and we saw evidence of very fine layers that formed in the bottom of lakes. And so that was a different environment where you've gone from a kind of a dynamic water environment of flowing in a stream to one where there's a standing body of water in a lake. And so that changed the kind of rocks that were deposited, and we could tell it was a lake. I think the answer to your question that I think is most significant is the environment that we didn't know existed, and now we do know with curiosity, is how long those lakes lasted. So not just a lake for one short period, 1,000 years, short geologically, but lakes that lasted for enough time that 600 vertical meters of rock were deposited from the silt, falling out of those lakes. That means they were probably there for millions of years, tens of millions of years.
Yeah.
Yeah, there's the rounded pebbles.
So, like, if you think
I
about
yeah, go ahead.
that, well, I'm just sort of imagining that environment. Like I have sort of like two ideas in my mind about Mars. Like, one concept is that Mars was always cold and dry. It had water briefly, and then it dried up or got sucked into the interior of the planet, and it was gone. And then you've got this other idea of it being warm-ish and wet for long periods of time. What version of early Mars is starting to form in your brain when you think about Mars today?
I love the question because it's one of the big open questions that's been around from the first day I started working on Mars, like almost 30 years ago now, to now. Was Mars ever warm and wet? We've always wanted to know this. And curiosity hasn't answered that question in a black and white way. But what we have shown is that water persisted for a long time. And so to me, it's harder and harder to imagine a wet, cold Mars, icy wet Mars, that allows a lake to be open on Mars' surface with water evaporating and needing to be recharged by streams continuously. And so I think that does push us towards a wet, warm, early Mars. But the climate modelers are still struggling with how you get that in the atmosphere.
Like right now, the pressure of the atmosphere on Mars is like 1% of Earth pressure. What kind of pressure would you need for it to support warm lakes for long periods of time?
Yeah. Whether the lakes are cold or warm, as long as they're liquid, meaning just above freezing or nice and room temperature, either way, you need a much thicker atmosphere than today to keep the lakes from either freezing or boiling off. And so you probably need, half a bar, meaning half of what Earth's atmosphere is or so or more. It still doesn't mean that it was warm. So the part that climate modelers are struggling with is even if you put half a bar of CO2 on Mars, it doesn't raise the temperature enough to make it warm enough to have like tropical storms and things like that. That would give you an obvious reason why you had so many lakes. You still could have half a bar atmosphere and it'd be just above freezing, and the lakes always have ice around their edges and things. I just find that harder and harder to believe the more evidence of liquid water we find in a place like Gale.
So is there a place on Earth that would stand in for early Mars, do you think, at this point?
Yeah, it depends what side of that controversy you're on.
Yeah.
It's not really controversy, but what side of the warm wet versus cold wet, and the cold wet crowd would say Antarctica has some analogs. There's lakes in Antarctica that are perennially frozen over with an ice cover, but the lower parts of the lakes remain liquid. And then what you're showing on the screen now is a place in Chile, the Atacama Desert, where you might have an example of a warm, wet early Mars. And there's like salt deposits around, and that's pretty close to where we might be in the sulfate unit these days. So this could be what early Mars looked like in the warmer view of the world.
So what's next? I mean, you're in a wonderland right now in terms of science. Where do you see things going over the next couple of years?
Yeah, I mean, we're of course most keenly aware of our mortality these days. We're aging, as you know, the road getting older. And so we want to make the most of, you know, the 3, 4, 5 years, maybe if we're lucky, we have left. Really limited by power. Of course, something technical could go wrong tomorrow, like something really critical could break. But just in terms of the power supply, which is the known way that the rover will one day, you know, fail to operate, probably, you know, 3, 4, 5, 6 years if we're lucky. And we would like to get through this sulfate unit and really answer that question of, now that we think we see evidence for a big change in Mars climate, from wet to dry and maybe from warm to cold, what did that mean for the prospects of life? Is this the end of the habitable era on Mars, or did it continue even while the sulfate unit was being laid down? If we can answer that, then we pretty much answered everything we signed up for when this mission was first chosen to go to Gale Crater.
And so when you think about the kinds of capabilities of Curiosity, and then add that the capability of Perseverance, what kind of capability do you think could go next to carry on the search?
So, I mean, Perseverance is a big part of it. The Mars program strategy that started like right around the turn of the century was sending orbiters to map the planet, using those data to find landing sites to explore for evidence of long-lived water, like with MER, the Spirit and Opportunity, and then evidence of habitability with Curiosity. That was kind of our place in the strategy. And then the next thing was send a spacecraft to a habitable environment and return samples so that the best laboratories on Earth could figure out if life ever took hold. That's something that we cannot do with Curiosity. We've done our job showing that all the conditions were there, but you really need the samples back on Earth to see if life ever took hold. And so, I mean, in that sense, that's where the story ends. Perseverance, getting the samples back from a habitable place and really figuring out if life on Mars ever was a thing. I think after that, or even hopefully in parallel with that, there's still so many other questions that we have not had a chance to answer because we've focused our efforts, you know, NASA has focused its efforts on this question of habitability and life. So, you know, the polar regions is one thing I'll throw out as something that I started working on the Mars Polar Lander, believe it or not, 1999, which ended poorly. But I think there's a record of climate there, kind of like we were discussing before this started, that you could learn a lot about the recent few million years of Mars by exploring the poles.
Right. So it's like the search for life on Mars with the Mars Sample Return mission will be science's best shot at answering that question, apart from shipping an actual lab and geologists to Mars to set up and including Nick to actually look for life. But there are a ton of non-life related, very interesting questions about Mars, about its history, its geology, its atmospheric activity, its glaciers, etc.
Absolutely. I mean, the thing that it's obvious to all of us, of course, but it is a planet, and it's a planet that is on the, you know, has so much variety and complexity. It's not a dull and dead place, especially in the past. Had more in common with Earth than probably things that were uncommon. And just, you know, this picture that we're viewing now, this is something that just came down a few weeks ago. I think it's one of the most beautiful panoramas we ever took with Curiosity. And we're right at that interface with those rounded buttes of the sulfate unit. So as we're climbing higher in the mountain, we're getting into this just amazing topography, and we're just going to be in this for the next 3 to 5 years. And we're looking these days up at the walls of things just as much as we're looking down at our wheels, and that's new for us on the mission, and it's fascinating.
I think the geologist in you've just has got to sort of feel like you're walking alongside a mountain or alongside a cliffside, and you're just staring up and looking at the layers. It's almost like you're there.
Yeah, it really is. There's this other thing that really struck me. This is our 10-year anniversary, and one of the things that's most impressed on me over 10 years is how Earth-like Mars really is, and how much we all can take our experience from walking around deserts on Earth and seeing so many similar things play out as they played out in Mars history. It really just makes you forget sometimes that this is 100 million miles away. You just want to run up that hill, and see what's going on behind it.
Yeah, amazing. Well, congratulations on 10 years of successful science on Mars. It's been wonderful we have got to have 1,000 stories on Universe Today about Curiosity, and we will continue to check every single event as it happens. And congratulations on all of the science that you've done so far. If people want to keep track of the work that you're doing, stay on top of all Curiosity stuff, what's the best way to do that?
I think the best way to do that is through the JPL website that's specific for our mission. And I should have included a URL, but it's www.jpl.nasa.gov is, of course, the JPL homepage. And you can find your way to Curiosity's part of that. There's a map you can use to see where the rover is every day. There's also a daily or a few times a week blog that our team members write, which is a really great way. It's called the Mission Update on that website. It's a great way of keeping track of the mission. And I just want to thank you very much for all the stories you've covered. Thank you so much for inviting me and keeping track of the mission.
All right. And if you do find life, let us know.
Okay. You'll be the first call.
All right, thanks.
Probably
not,
but
probably
the president.
President, then us. Yeah, we got it. We understand. All right. Thanks a lot. All right, let's move on to the space news related portion of the episode. So let's start. Nick, you've got a couple of stories you want to get onto. Let's just tail right into what's happening with Curiosity. What's happening with Perseverance?
Well, Perseverance has had an exciting time recently. Actually, just earlier this month, there were a couple of papers that came out that really detailed some of the cool findings from the start of the mission through basically the present. There were two main instruments reporting. One of them was the sample analysis team that was looking at what are the rocks on the surface. So this is a mixture of Sherlock and Pixel and several of the imagers, ChemCam, looking to say, what exactly do we see here? See, before we went to Jezero Crater, there's a lot of debate about what this floor unit of the crater is. Because from orbit, it looks really, really weird. It actually had a strong signature of calcium carbonate, but then also olivine grains. And we were having a hard time sort of making sense of that. Like, is this chemical sedimentary rock, like a limestone, that has a bunch of olivine that must have weathered and fallen in? Or is this a carbonatite, which is a very weird type of lava that we wouldn't have really expected on Mars? Or is it something else entirely? And turns out, there are little bits of carbonate in there, but it's actually a really thick layer of basalt. This is one of the few times where we found basalt that looks a lot like the meteorites that we get back from Mars. In fact, this is split into 3 different layers we see. So this could be just one really big flow that differentiated, or 3 totally separate flows, or literally any combination in between.
Now
so we've
Jezero Crater, sorry, let me just understand. You've got Jezero Crater, you've got this area that was carved out by a massive meteorite a long time ago. There would have been eruptions before that, and then it was digging out this area. So are you saying that there were eruptions after the crater was carved out that then filled in part of the crater?
Well, there's still a big debate on that. This could be an impact melt at the bottom of the crater. This could be volcanics from the nearby Syrtis volcanic system, or it could be something else entirely. We're not really sure because we don't have context for where this lava came from. For that matter, we're not entirely sure it was a surface flow. It could have been a sill that's been eroded into, although that would be really kind of weird to get to. But what we see is
the water and the wind had eroded in to the point that this old volcanic activity was made obvious.
yes, and if that happened, why I'm saying that's unlikely is because you'd have to erode and then deposit the delta on top of it.
Mm-hmm.
So you're talking erosion way back early in Mars's history. So they saw this on the surface, different units. They were able to use their ground penetrating radar to see different layers, some of them steeply tilted, that show that this keeps going underground, which is why they could assemble a cross section, even though they were just driving around on relatively limited topography on the surface. So one of the reasons why I thought this was so cool is because I'm an igneous petrologist. I love volcanic rocks. And this is a mission that's looking for life, aka really not igneous rocks.
Yeah. Sedimentary rocks.
But boy, did they find some. And not only that, they found some that look like Martian meteorites.
Right.
So this is the kind of thing where we can start to build.
These rocks were also a type that was created in a fairly wet environment, right? They're like olivines and things that are surprisingly large amount of water mixed in with the lava.
Actually, olivines usually something we think of as coming out of a early hot mantle on the Earth, at least. And there's no reason to suspect differently for Mars. So these are usually what we call very primitive basalts. That is stuff that's most directly accessing the interior of the planet. So this isn't stuff that indicates a watery environment. There's plenty of stuff here that indicates water, but it's not this unit. This unit is just interesting volcanics.
Mm. Got it. So I guess, what do you think this is trying to tell us?
Well, honestly, my favorite lesson is everywhere we look is more complicated than we think it will be before we get there.
That definitely feels like a common thread along all of this, for sure.
It's one of my favorite lessons from space exploration. We think a place will be boring, but we decide to go look at it anyway and go, wow, that's really not boring. Jezero wasn't going to be boring no matter what, but we didn't expect people like me to be super excited about the first rocks we saw. Instead, this is 100% my wheelhouse. This is cool.
Yeah, I mean, this idea that scientific instruments or missions are designed to answer questions. They're not. They're designed to create questions. They're question factories as opposed to
that's one of the
answers.
Problems with science. When you answer a question, it usually leaves several more.
Yeah, totally. Yeah, I think it's super funny that you kind of get into that. So I guess what would it? I mean, are there any plans to continue sticking around, or is Perseverance just
No,
kind
they've
of
already moved up
they've
into
licked
the
the rock and go, oh, not life, moving on.
Yeah, they spent a solid year looking around this, trying to figure out what it is, sample it well, and give a really good context for what this floor unit is, particularly since it's ended up being so unexpected. But they've moved on since, and now they're looking at some of the furthest out deposits from the Delta. So we're really starting to get into that sedimentary environment and seeing a lot of things that look a lot more like the kinds of stuff we saw with Curiosity. Now, I'm sure there will be many comparisons over the years, and I don't want to start that. But we're moving into that sedimentary systems where we expect to see signs of life, if there was any.
Yeah. Really interesting. Okay. Let's move on. I guess we got to talk about DART. I hope we all watched it last night. Did you watch DART as it crashed?
Not live. I was asleep, but man, the images the next morning were quite something, weren't they?
Yeah. Yeah. It was perfect for me. It was like 3:00 in the afternoon, so we watched it live. I was like, my wife came into the house and I'm like, oh, hey, do you want to watch a spaceship crash into an asteroid? And it was, it was about an hour of coverage from NASA, and you got this tiny little dot, and then the shot just kept bigger and bigger and bigger, and then in the last minute, it just was like, and then every frame, it was just the asteroid, and then you went past the asteroid to the target and crash.
Mm-hmm.
How did it go? According to
Yeah,
NASA?
I mean, apparently it went very, very well. It was quite a spectacular view. We got live accounting for the time lag of about 40 seconds or so, live footage of the collision as it happened. We got the driver's seat view, and then that amazing dust.
It's funny.
Cloud, the ejector.
Did you see that last frame? Yeah.
Red.
There's that last frame where you got like a little bit. Yeah, you got the little bit at the top and then red, because I guess it had only been able to transmit that much data back before it crashed, which I thought was great.
Highly evocative.
Nancy is mentioning in the comments that you have to go and type NASA Dart in Google, and you'll see another one of their weird little browser tricks. But yeah, so
it's a very cute little homage.
Yeah. So I guess what news have we gotten from Dart since we saw that impact?
Wow. I mean, I know there's a lot of work still needs to be done looking at those results have come in. I don't know. Has anything been released yet directly to because the core purpose of the mission, right, was to see how much would we actually redirect that I have blanked out. Not Didymos, Dimorphos.
Dimorphos. Yeah. I think we're looking at. They said a couple of weeks to months for them to be able to calculate the change in the
2
orbit
months.
So it's going to be months before the change adds up to the point that it's actually detectable from its previous orbit. So it's going to take a while.
Yeah. I understood they were hoping that the orbital period of the two objects would change by about 10 minutes or so. So I guess you'll just have to wait and see how that goes.
Mm-hmm.
But what I found, what I really loved about this, the big surprise for me was that amateur observers sitting on Earth, even not so far from me, sitting in South Africa, watching it live, saw it happen. Actually saw something happen through the 12-inch telescopes. It's incredible. There's a local astronomer here, Berto Monard, who I didn't know much about before this, which is surprising because he's very, very active. If you Google him, you'll find the number of supernovae he's detected. He's the first amateur to ever detect the afterglow of a gamma ray burst. He's a very prolific and very serious observer. He's got a lot of papers published, but he's also he's not a very public figure. I've met him once or twice at Astronomical Society symposia, and Gianluca Masi from the Virtual Telescope reached out to him yesterday and said, "Is there any chance we can see if we'll see anything?" And he agreed to do it. And as the event approaches, it's raining, it's cloudy, and they'd pretty much written it off. And then at the absolute last minutes, the rain stopped, a gap in the clouds opened, Berto runs out, opens the observatory roof, starts filming, and they find the astronaut. Is I think on the screen grab there that we've got, it's a fairly faint star. You see there's a fairly bright star in the middle and to the right. That's about 11th magnitude. And to the right of that, there's quite a faint little object. And within a minute of the stream starting, that object visibly brightens and becomes the brightest object on the screen.
Mm-hmm.
And here's a progression of images that were captured over about, that's about 10 minutes, I believe, if I remember from watching that stream. I mean, we've seen much clearer views of this. The official footage coming from professional instruments. You see this lovely big cloud, but we also saw that from the ground in a private observatory with a little 12-inch telescope.
Yeah,
and it's
you could see in that that image. You could see the puff of the debris in this telescope. Yeah, I've since seen a picture from James Webb is out.
Mhm.
And then there was the actual CubeSat that was flying with it. It's released its images, and there was some really interesting dust lanes in the debris cloud that have set some of the, I guess, lunar geologists and scientists on Twitter quite a buzz, and has gone and done one of his giant tweet storms going into why the shape of the was unexpected and surprising, and what the implications for it are. I think Pamela was talking about this before the show, that it has to do with sort of similar to why we see the rays coming out of craters on the moon and such. But really interesting. I hope the dinosaurs are impressed that we try to exact our vengeance against an asteroid.
Let's see. The Onion had an image of the asteroid shoots back.
Yes, I saw that. Yeah. So, is there anything else about this story that you've been tracking, Pam? You were going to say something?
Yeah, I was just wondering if anyone else in other places in the world had also tried, the amateur astronomers tried to see what they could see. And I don't know if anybody's heard of anything, but yeah, I didn't even realize they were doing that. I had this on my calendar and I whiffed. I completely missed it.
You missed the DART impact?
Yeah.
Oh.
Yeah, I did.
Yeah, it was pretty great. People are saying that my
Dolby
audio
video,
is
right?
getting a little janky. Are you guys able to hear me okay?
I can hear
Yeah,
you
you
fine,
sound
Yeah,
good.
loud and clear.
Yeah. Okay. All right. So it must just be the output somehow. Oh well. And I sound good to Pamela, so who knows? Internet. Elon. All right. Well, good. That's fantastic. I'm really glad we got such cool pictures from amateur astronomers, and also we're going to get cool pictures from the professionals as well. It's pretty great. All right. So let's move on. Pam. Apparently,
Yeah,
there is a really bright planet in the sky right now.
Yeah, there is actually. I'm really impressed by those pictures because I really like to talk to people about the things they can do. And that's absolutely the kind of thing that you can do. You can go out and you can make observations as an amateur. Yeah, you're talking about Jupiter, of course. And it's kind of cool because now we've got planets in the evening again, which I was really missing because I
know
much later than I get up early. So we actually have two.
The planets are a little out of
Saturn.
sync these days for me, because like my favorite is when the planets are visible in the early summer, like June or so, and that's where they had been.
Okay.
But now the planets are getting nicely visible in October, November, and that's when my bad weather shows up, and I don't have a good chance to really be able to see things. Yeah, so we have nice clear skies through the middle of the summer, but then in the fall things get a little hairy. So it's nice when all of the planets are up at times that are very, that I have a chance at nice sunny sky, clear skies. Anyway.
Sure. I get it. So yeah, I mean, have you been able to see Jupiter at all? It's
yeah.
incredible.
I got out the binoculars and the telescope. Just
good.
Yep, no problem. Yeah, it's funny. My wife was like, "I want to see Jupiter."
So,
I'm like, okay, all right. Let me get this all set up. Yeah.
Yeah, and the moons. Oh, I love showing people that. Oh, do you see the moons too? How many can you count? And the kids always see more than the adults do. I love that part.
Yeah.
So just some highlights for the next month or so. We do have an eclipse coming soon. There is a meteor shower. Unfortunately, it's during the full moon. I do want to talk to you about some cool activities, 4 to be exact. Then there's a Globe at Night project, and I'm going to talk about a couple like conjunctions and so forth. Yeah, there you go. So the meteor shower unfortunately isn't that impressive either. It's basically, we don't even have a date range, October the 9th. But the nice thing about it is late evening. Sadly, we're going to have that big old moon. 6 per hour, and they are saying it's from Giacobini Zinner. Anybody know about that? I don't know about that. I'm thinking I may need to update this chart because clearly it's, I mean, they're calling it the Draconids. It must be kind of out of the Draco area. So anyway, yeah, we've got some.
Yeah, I've heard of the Draconids
cool-
before.
Yeah, but not very many. 6 per hour. I mean, think about it. That's 1 every 10 minutes, which even 1 a minute is a long time to wait. In our computer era, we're very, very used to things happening almost instantaneously. So yeah, you go out and it's 60 per hour. It's still 1 a minute. Seems like forever. So the events I want to tell you about is Space Apps. It's a NASA thing. They're going to be running. That's the next slide, Pamela. They're going to be running October 1st and 2nd. They do this every year. And just a brief quote, Space Apps inspire local communities to come together, think intensively, and create solutions to important problems. But these are available to you anywhere in the world. There are local groups that come together to work on these things. Then we're going to have the 4th round of Nominate a Student with Perseverance. That's opening on October the 3rd. That's the next one. Next slide. This is 6th through 8th grade students in the U.S., the public, private homeschools, any of them are eligible. And there's some really cool awards. They've added a couple too, I noticed. The Space Education Symposium is coming. That's, let's see this next slide here. And it's interesting because I did not realize they're having this opening event. And this is a Human Space Program. That's a Frank White group. The pre-conference is October the 27th. I guess it's a live in-person thing, but the symposium on November 12th is a free online event if people want to tune into that. Then I want to tell you about this Regeneron STS, which stands for Science Talent Search. We had our first student guests on our show last month, and one of them told us about this wonderful award. I mean, some of these prizes are big for students. Like, I saw $250,000 in the one case. They have kind of 4 in general: the Science Talent Search, the International Science and Engineering Fair, Broadcom Masters, and Affiliated Fair Network. So yeah, if you like that kind of stuff, try to win a prize. I think they have various definitions of who can enter that kind of thing. But yeah, I would definitely go to the site. Let's see, where's the... Yeah, shoot, I didn't put the name here. Sorry. We've got another Globe at Night. That's October 17th through the 26th in the Northern Hemisphere. You want to look for, how do you say GRUS? G-R-U-S?
I don't know how you say that.
I have it backwards.
Groos?
Sorry. That's the Southern Hemisphere. Yeah, so maybe somebody in the Southern
Alan, you're in the
Hemisphere knows.
Southern Hemisphere. How do you guys
then
say
the
it?
Northern
I say Groose, but I never did. And so
How do you say
I just
Groose.
I say Groose, which I imagine is
Awesome.
it's
Latin,
Latin, isn't
okay.
it? I think.
Yeah, I don't know. They have a picture of a bird there, so I don't even know what it is. Of course, being in the Northern Hemisphere for my whole life, I know very little about the Southern Hemisphere. They want you to look for Pegasus in the Northern Hemisphere, and each project goes 10 days. The idea is to go out, take pictures, compare, and report on the site. And I think it's a great citizen science project to make a real contribution. And then they have 6 easy steps, they say. They have some nice charts that you can look at and compare what you've taken a photograph to what's visible in the sky and help them out. And they get thousands and thousands of these every year. So we've got some cool things happening in the fall, of course.
I got to get
Groose,
up here.
okay.
Groose.
Yay.
Yeah. So it is Latin for the crane. And
Okay,
it
awesome.
absolutely looks like a crane. Like if you look at Groose, you look at the shape of the stars, it is, I mean, I would say it's a Canada goose, but it is definitely a crane when you look at it. So
Okay. All right.
There you go.
Cool. Yeah, and they
There you
don't
go.
always look like the thing that that they are
Yeah.
supposed to be. So I think some of the folks in the previous generations were enjoying some mushrooms. But anyway,
No,
so
no,
some
it's
cool things
like
to watch for.
this is like the Big Dipper looks like a Big Dipper. Goose the crane looks like a crane,
Yes.
no question.
It's a classic southern constellation.
But, I
mean, like
and
Orion.
sorry,
That's okay. So some things to watch for. October 2nd is the first quarter moon. On the 5th, Saturn and the moon are in conjunction. I really love those conjunctions, and there's lots of science that can be done with those kinds of things. On October 8th, Jupiter and the moon are in conjunction, and Mercury is at I think its greatest western elongation. That's going to be in the morning again, right? Like I said before, the
I don't know.
Draconia
I'll
meteor
never see
shower
it.
is. Sorry. Yeah,
Doesn't matter to
I
me.
know.
Yeah. There
Yeah,
are
I
only
hear ya.
there are only 7 planets in the solar system.
Got it. Okay. Even
Yeah.
Pluto and others
Mercury.
have been demoted now. Okay. Got it.
Yeah.
it.
Yeah.
The
Mercury just
9th of
doesn't
Bull
is
Hunter
dead to
moon.
me.
Yeah. Sorry. You got to move somewhere flat or go visit there.
Yeah. It's got to change its
full
orbit.
Oh, I see. Okay.
Yeah, I'm not
Full
I'm
Hunter
not
moon
I'm
is on
not
the 9th.
moving.
That is. Got it. Okay. It's going to interfere. The full moon's going to interfere with the meteor shower. Of course, it's not that impressive either. So, anyway, on October 15th, we've got Mars and the moon in conjunction. Another really great sight, I'm sure. On the 17th is the last quarter moon. And I'm going to talk about this more next time because I'll be back before this happens. On October the 25th, it's the new moon, but it is a partial eclipse as well. I have here Venus and the moon are in conjunction on that day as well. So yeah, tune in next time and I'll go into more about that eclipse and maybe even the next one. I think it's November something. So yeah, stay tuned.
Okay. Right on. Well, we got a little bit of time left, so why don't you give us one last update about glass on the moon, moon glass?
Ooh, I get to talk more science. Mwahahaha.
Yeah.
So this was actually a paper that was published today. Like it came out literally this afternoon. And it's looking at one of the returned samples from the Chinese rover that went out, picked up a sample canister and sent it back to Earth. Sample return from the moon. And they're looking at little glass spherules in it. These are what we call impact melt glasses. So when a meteorite hits, some of the ground that it hits and some of the impactor vaporizes and forms little droplets that come out. And when it does that, it resets some of the isotope systems are used as clocks, what we call isotope chronometers. So you can actually figure out how old each of those impact glasses are. They did this using the uranium, thorium, lead system, and they figured out what the ages were for something like 188 of these glass spherules, which is a lot of isotope age work. And they found that they clustered around certain ages. One of the ages that these clustered around was about 68 million years ago, which is within error of the extinction event for the dinosaurs.
Huh.
That's within error of Chicxulub, because they had plus or minus 3 million years. Chicxulub was 66 million. So scientifically, that's within reason. They may be the same thing.
Pieces of vaporized dinosaur rain down on the moon?
No. What they think may have happened was that it wasn't just one big impactor that hit the Earth. It may have been a few things, some of which happened to hit this region of the moon. They actually went out of their way to do a lot of dynamical modeling to look at what were the craters that happened in this region, because the region the rover is exploring is a pretty homogeneous geologic unit. It's one big lava flow. And so the different craters hitting that will sample different ages from the same sort of material. So you can kind of get this idea of when each of these droplets formed. And it looks like a lot of the major events that happened on Earth also happened in this region of the moon, which suggests it's not just a clean one object strike each time. It's a lot of little objects that come through, some of which hit the moon.
That's really interesting.
That's a really cool result.
So, like, were they trailing the larger object? Was it like getting hit by a shotgun? Was it just that? Okay, yeah.
I don't have the foggiest.
Yeah, yeah.
What we have is we have impact glasses that formed on the moon from lunar materials that cluster around dates that are related to Earth's major impact-related extinction events.
Yeah.
There are also a few other dynamical events that they were trying to draw connections to elsewhere in the solar system. But it's really just an interesting, different way of looking at how you can use sample return in lunar science to say, this can help us reconstruct the dynamics of the solar system and look at some of these events that happen on Earth or elsewhere based off of what the record on the moon looks like. Because it's
so
just been sitting there, soaking up this record for most of the history of the solar system.
Very cool. Thanks, Nick. And hot off the press. I like that. Now
I try.
Now, so the one big story that we should probably mention quickly is that Space Launch System has gotten the official no-go plan. Of course, with the hurricane bearing down, they decided to move the rocket back to the vehicle assembly building, which had a minor fire. Everything's fine, but it also caught on fire. But anyway, so now it looks like we're not going to see a launch of SLS until late October, more likely November. There's a whole bunch of things now that engineers are going to have to do. They have to make sure that its self-destruct system still works, but not by self-destructing it. There's other ways. They have to recharge a bunch of batteries.
We're still having a possibility of the October 3rd window, but
I know, we definitely called it.
Okay.
Yeah. But yeah, I could be wrong. But that was my understanding, was they were definitely calling it for and bringing it back to the vehicle assembly building. And at the same time, of course, we see Starship putting itself through the paces. We've seen a 7-engine test on Booster 7, and that went successful, and the rocket didn't explode. So now they've only got another 24 engines to go to fire all 30 simultaneously on the Super Heavy, which is ludicrous if they can pull this off. Then they got to stack Starship on top of it, and then they got to launch them into orbit without testing Super Heavy before. Anyway, my point is, Elon Musk said maybe we'll see a test of it in October, more likely November. That seems ambitious to me. So I think it is still a dead heat on who is going to launch first, SLS or the Starship Super Heavy stack. Crazy. I want to see both of them.
Are you
launch.
taking bets?
At least once.
Are you taking bets?
Are you taking bets?
I'm thinking Elon. Personally,
no, my money's on SLS. No, my money's on SLS. So here's my prediction.
Okay.
SLS launches in November. Super Heavy launches in March. That's my guess.
Okay.
And the SpaceX fans are freaking out right now. They're cursing my name. Musk said November. That means November. But, they're not accounting for Musk time. But when I account for Musk time, when I do the calculation, I get March. So hopefully we will see a launch of one or both of these rockets in the coming months, which would be exciting. Starliner is not due till next
We haven't had
year now at this point. So
there are several of us that have, small, informal, not for money betting pools on when SLS will launch. And right now I'm not sure when it's going to be, except I'm pretty sure it's going to be a holiday. There's one a month coming up for the next 3 months. And I'm not sure if it's Halloween, Thanksgiving, or Christmas, but it's going to be one of them.
Yeah. Pamela, we did a whole show on how mission seems to happen on holidays and how multiple holidays a year are ruined. There you go. Pamela saying that DART was Rosh Hashanah. So it never stops. It's holiday.
There's New Year's and
always.
New Year's Eve. Don't forget.
I don't mean to be a naysayer,
yeah,
but I'm kind of betting SLS launches on Christmas.
Yeah, do you remember Webb launching on Christmas? I mean, it just goes on. Yeah. All right. Well, we've reached the end of our show, so why don't we wrap things up? Nick, what are you working on? Where can people find out more?
I am working on a lot of different things. It's kind of hard for me to keep track of these days. But you can talk to me on Twitter. I'm the Wandering Scientist. You can find me on Instagram, where I occasionally still remember to post. But Wandering Science, wherever that is.
Excellent. Alan.
Yes, I've got a couple of University Today articles in the pipeline, and I'm hoping to
Do you?
get hold of
Because
yeah.
your better half has been writing some really great articles for Universe Today. I've been really
Oh
enjoying
yeah,
them.
she's really coming out of her shell,
She's a great writer.
taking my limelight away. She is. She's been doing it
Yeah.
for years and years. Yeah, but I'm also hoping to get an interview with Berto Menard.
Mhm.
Oh, sorry, we're talking over each other there. I was hoping to grab an interview with Berto Menard, put him on the podcast. It's Urban Astronomer. Don't know if he's going to go for it. He's not he's not a publicity guy. He's a quiet, do the science. But wish me luck. Maybe I'll get him on the air. Otherwise, find me on Twitter.
Fantastic. Pam.
Well, thanks, Fraser. We're still doing our Friday night show live every Friday at 9 p.m. Pacific time. Everyday Spacer, the Facebook page, and Everyday Spacer, the YouTube channel. Our next guest is Miss Covey Denton. And then we're going to announce our first annual Everyday Spacer Awards. And then we're going to have Mike Simmons back. He's a real interesting guy. And anyone can share a live with us as a guest. We do open mic nights sometimes. We have listener questions. We have a lot of fun stuff every Friday at 9 p.m. Pacific time.
Perfect. Actually, we're going to have Mike Simmons here on the Weekly Space Hangout next week, and he's got a pretty exciting new project that he's working on. Like, he's always figuring out ways to make the world a better place, and I'm looking forward to hearing what he's got cooking this time around. All right. Well, thank you, everyone, for joining us this week on the Weekly Space Hangout. Thanks to our special guests. Thanks to all my co-hosts. Thanks to all the moderators. Thanks to everyone on YouTube and on Twitch. A special thanks to Nancy Graziano, as always, for herding all the cats. And thanks to Pamela for engineering behind the scenes. Thank you, everybody. We will see all of you next week.
Good night.
Goodbye.